Hey guys, Mr. Beeler again. Today we're talking charging systems. I've got my 442 in the garage today. We're using it as an example for identifying parts of the charging system. The alternator is the heart of the charging system. This is what creates voltage and amperage for us to charge the electrical system. We did some assignments on starters and batteries. The batteries are source of power to start the vehicle or to supply power to the starter. The starter is what cranks the engine over. Once we start it up, we have to replenish that battery, have to charge it up. We also have to supply voltage to the rest of the system as we use our headlights, our taillights, our blower motor, and other such electrical equipment. This is our alternator. It is driven by a belt. This one happens to be a V-belt. Most of the stuff you guys are going to run into will be serpentine belt. The aluminum part is our case. We have a fan. This is for cooling. Internally, we have a stator, which stays put. I like to kind of mix the two together, stay put and stator. And then we have a rotor inside, which rotates. We talked electromagnets and starters. How this works is we have brushes and two slip rings on the rotor. We turn that into an electromagnet. As it spins via the belt, we have magnetic lines of flux. As they pass through a conductor, which is our stator, they will induce a voltage. Now this voltage is alternating current. That's what they call an alternator. We create an AC voltage that we then convert to DC voltage. We have diodes. Diodes are a one-way check valve. This allows us to have a direct current. Now, the faster the spins, the more power it can make, the more voltage it can make. We have to regulate that voltage. That's where the voltage regulator comes into play. This keeps this thing from overcharging or undercharging. Normal charging system is 13.5 to 15 volts. If you overcharge, you can damage the battery, you can damage other electrical components in the vehicle. So that's where the regulator comes in. I'll roll you around to the back side so you can see some of the electrical wiring. On the back side, there is a positive cable. This goes to the battery. So when this thing starts making voltage, it has to get it to the battery. Some manufacturers put a fuse link, which is a circuit protection device, or maybe they'll put a fuse in line. That way if something shorts out, it blows that instead of burning out the wiring. This particular setup, there's a plug-in that tells the rotor in there, when we energize it, when we energize the field, it tells it to turn on. So this setup, when you flip the key on, when it's in the on position, it energizes the field in the rotor, creates our electromagnet. When the engine is spinning, this will create our AC voltage. Some of the newer stuff, they are computer controlled. So the ECM monitors voltage, and it tells the alternator when to charge, when not to charge. So there's more to it than just a simple on or off from the ignition switch. If you're diagnosing one of these, make sure it's getting the signal to turn on. I have seen older Chevy trucks, guys have blown a fuse or stole a fuse out of the fuse box for something else, and it happens to be the wire that turns this unit on. If you don't send power to it, it's not going to turn on. If you put a new alternator on it, it's still not going to turn on. It has to be getting that power. You can also check on this post back here that goes to the battery. You can check for your charging voltage and compare it to what you have at the battery to see if you're losing any volts in that wire. We come back around to the front. This one has just a standard V-belt pulley on it. Some of the newer manufacturers are using a one-way clutch. When you see them on a serpentine setup, they're going to be a little bit deeper, a little bit wider than a standard serpentine pulley. There's a one-way clutch, and I use that for vibrations. It cuts down on belt wear. It's also a fuel mileage thing. Those things can go bad. What will happen is that one-way clutch fails, and it'll allow it to spin freely both directions. The belt's going, the pulley's spinning, but it's not turning the insides of the alternator. Some other problems we can have if these things fail or don't put out enough, if you have belt slippage. If the belt is slipping, it's not going to turn the alternator efficiently. You're going to have some loss there. It's not going to charge as much. Voltage regulators can go bad. They can go bad and not charge. They can go bad and can overcharge. I experienced a customer one time had a battery that was cooked. There was steam shooting out of the vents on the battery. The charging system had maxed out. The charging system tester we had only went to 24 volts. He was maxing out the 24 volt range. So he was over 24 volts charging. The diodes can go bad. The diodes, remember, take the AC voltage, turn it into DC voltage, because that's what we use in automotive is DC volts. If they go bad, you'll get some AC voltage into the electrical system. I'm going to do another video with my Suburban with it running to show you how to test that. We use the Cutlass or the 442. It's a little too loud. You guys won't be able to hear me. Other problems, there are bearings and brushes in there. Just like starters, those brushes can fail. We can also have chemical contamination. So if you got a bunch of motor oil in an alternator, they can have issues. Brushes can go bad. Bearings can go bad. When the bearings go bad, you usually get a whining sound. If you guys remember, we tested idler pulleys when we were in belts junior year. We checked for noise. You'll get a similar noise in an alternator. So that's all I have for today. I will have another video showing you guys how to check voltage on the alternator and how to check for AC voltage. I will talk to you later.